Hello friends, in this video we are going to see what is significant figures. This is the last point in the first chapter, that is units and measurement. So before watching what is the significant figure, we will first see what is the least count. The least count is the smallest measurement that can be made using the given instrument. Suppose we have a ruler. Have you watched the ruler? So there are some numbers here. So what is the minimum number you can measure? That is called the least count. So in our regular ruler, we can count 0.1 centimeter, or we can say 1 millimeter. So this is the least count of our regular ruler. Similarly, we can have least count of other instruments. We are going to see in our practicals vernier caliper, micrometer, screw gauge. They also have some least counts. So we will see them in the practicals. Now we will see what is the significant figure. So we will see there are two definitions. This definition is given in our book. The definition says the number of digits in a measurement about which we are certain plus one additional digit, the first one about which we are not certain, is known as significant figures or significant digits. So I will explain this with one example so that you can get clear idea about what is significant digit. Suppose we measure one distance from our regular ruler. Let's say it is 1.5 centimeter. Now suppose I take another measurement and it comes out to be 1.4 centimeter. Now here you can see one is certain, this is fixed. Now this digit is not certain, or we call it as uncertain. But what we said, we can take all the certain units and the first one which is uncertain. So here in this or this measurement there are this one and this one. There are two significant digits or significant numbers or significant figures. Suppose we take the mean of these two quantities, then also we get 1.45. How we take mean? We add these two quantities, 1.5 plus 1.4, and then we will divide by 2 because there are two numbers. So we will get this number. Now check the significant figure here. So one is certain, but in these two both are uncertain. But we can take the first uncertain or not certain unit. So 1 and this 4, that means there are two significant figures. Now we will see the second definition. This is simpler one. So if you do not remember the first one, you can also try this one. This definition says each of the digits of the number that are used to express it to the required degree of accuracy starting from the first non-zero digit is known as significant figures or significant digits. So similar case, we will take the same example, 1.5. So in this, 1 is the first non-zero because we look from left side, left hand to right hand we go. Suppose there is another number, say 23.7, then the first non-zero will be 2 because we are going from left to right. So first will be 2, second will be 3, and third will be 7. So what are we going to see? We are looking for the digits or the numbers which give the accuracy to the measurement. So in this case there are three numbers, 1, 2 and 3. So all three are non-zero. So these are significant figures. So significant figure for 23.7 is equal to 3. Here 1 and 5 both gives some accuracy. So these are two digits. Two significant digits are there. So any definition you can remember. Now if the larger number of significant figures are obtained, then the measurement is having the greater accuracy of the measurement. So how we can say that? Suppose we measured 1.5 with some regular ruler, and now with another instrument, say vernier caliper, which we will see in the practical, we have measured it as 1.52. So definitely this will be more accurate because I am reading this 2, that is 0.02 centimeter we can measure from the vernier caliper. So this is better, or this is more accurate. So this says here there are only 2 significant digits and here there are 3 significant digits. So this is more accurate. Now we are going to see what are the rules to determine the significant figure, or for determining the significant figures. The first rule is all the non-zero digits are significant. So suppose 1.5 was taken, so we have taken that there are 2 significant digits. So suppose there is some larger number, right? So all the non-zero digits are significant. So this number will have the significant digits of 5, right? Suppose there is number 0.52. So how many non-zero numbers are there? These 2. So these 2 are definitely significant digits. But whether this 0 is a significant digit or not, we will see in the next rule. The second rule says all the zeros between 2 non-zero digits are significant. So suppose if I have written 0.502. So 5 and 2 are non-zero digits. So any 0 between this, so this 0 is in between this 5 and this 2. So this 0 is also significant. So there are 3 significant digits, this 5, this 0 and this 2. The third rule is if the number is less than 1, the zeros on the right of the decimal point and to the left of the first non-zero digit are not significant. Here not is important, right? So we will take one example. Suppose 1.650 is some measurement. So I can write, if I change the units, suppose this is in the centimeter, I can write this in meters like 0.01650. This is in the meters. Now in this 2 example, what we have to see, let's see. Suppose the number is less than 1. So this number is less than 1. The zeros on the right of the decimal point. So on the right of the decimal point and left of the first non-zero digits are not significant. So this 0 is to the extreme right. This is not to the left of the non-zero digit. So this 0 is significant. In this case also this 0 is significant. There is one more 0 here. Is this significant? No. Why? Because it is to the left of the first non-zero. This is first non-zero digit, that is 1. So this 0 is on the left of the first non-zero digit. So this 0 is not significant digit. So in this case or in this case, there are 4 significant digits, 1, 6, 5 and 0. The fourth rule is the zeros on the right hand side of the last non-zero number are significant. So as we discuss here 1.650. So 0 is on the right hand side of the last non-zero number, that is 5. So this is significant. So as we have discussed in earlier example, this will have 4 significant digits or 4 significant numbers. But in this case you should remember that in that number there should be some decimal point. So suppose I write this number, then this 0 might not be significant digit. That will change according to the example. So there is some kind of confusion in this. So whether we see 3 or whether we see 4. So to remove this confusion or we say ambiguity, we have introduced the order of magnitude. So what is the order of magnitude? Suppose there is one number, we can write this as a into 10 raised to n. Then this n can be said order of magnitude if this a is in between 0.5 to 5. So if this number, if this n is order of magnitude, then this a should be in between 0.5 to 5. Now let's take an example. Suppose the radius of earth is 6400 kilometer. To determine order of magnitude, we convert this into SI unit. All numbers should be converted into SI unit. So kilometer is not the SI unit, so we have to convert this into meter. So 10 to the power 3 meter is equal to 1 kilometer. So this will be conversion. So here also 6400. Now we have to convert this into number such that it should be in between 0.5 to 5. Now how we can do that? So we can shift these 4 points 1, 2, 3 and 4 to the RHS of the decimal point. So we can write point here to the left of 6 and then here we can write 0. So then this number can be in between 5 and 0.5. So as we have shifted these 4 digits, we have to multiply this with another 10 raised to 4. So what will this happen? 10 to the power 4 into 10 to the power 3. This will give me 10 to the power 7. And now we ignore these zeros. So in this case 0.64 into 10 to the power 7 meter is the radius of the earth. Now this is A and this is N. So order of magnitude will be N equal to 7. And now here we can check the significant digits. So here significant digits are only 2. So significant digits are 2.